Hi, geometry students. We're in section 10-3, and we have a theorem here that says, in the same circle, okay, or in two congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So if we have FG being congruent to JH being chords, then the arcs are also going to be congruent. So the arc measurement here will be the same as the arc measurement here, as long as these two are congruent. Okay. And here's the proof of that. Part 1. You don't have to worry about knowing the proof all the way down. You don't have to memorize it, but showing that there actually is a proof of it. Okay, and it deals with the congruent triangles. Okay, well, here's a real-world example. In a circular piece of jade, right, it's hung from a chain by two wires around the stone. Okay, we know that JM, chord JM, is congruent to chord KL. And if measurement of KL equals 90, then find the measurement of JM. Well, this is the direct example of the, so since the chords are congruent, then the arc should be congruent. Okay, so let's see how they talk about it. So we have our congruent chords, so we know the corresponding arcs are also congruent. And since we have one was 90, we know that the one we want is also 90. Okay, check your progress. Go ahead and pause your video. Try to find the measurement of TV. And if you said 85, you are correct, because that's the same, right, as arc RS. And we know we can say that they're going to be the same or congruent because it tells us that the chords RS and TV are congruent. Okay, let's use some algebra now. So in the figure, we have circle A and circle B are congruent. We also know WX arc is congruent to YZ arc, and we're trying to find WX. Try to find the length. Well, we know that the chords also should be congruent, therefore their measurement should be equal. So we should be able to say that 7x minus 2 should be equal to 5x plus 6. So I guess we could subtract 5x on both sides and add 2 on both sides. And we get 2x is equal to 8, or x equals 4. Since x equals 4, we could plug that in to the x there and get 28 minus 2. Let's see how they solve it. There you go. WX does equal 26. Okay, check your progress. We have two congruent circles, and we have the arcs congruent, and you want to find the value of LM. Good. If you said 13, you are correct. Okay, we have two theorems. If a diameter, okay, or radius of a circle is perpendicular to a chord, then it bisects the chord and its arc. Okay, so it shows right here that this is perpendicular. Okay, therefore it must bisect this. So xy, right, is double the length of xz because it bisects it. We also know our arc XB should be the same value as the arc BY. Okay, now 10.4 says the perpendicular bisector of a chord is a diameter or radius of the circle. So, example, if AB is a perpendicular bisector of a chord, XY, then AB is a diameter. So we know that, so basically this could have been like an if and only if type problem. Okay, here we go. So we have circle G, we have DEF being 150 degrees, and we are trying to find the measurement of DE. Right? Now, we see that the chord DF is perpendicular to a radius, so we know something about bisecting. So that should also be 5. Okay? Now, we're going to find the measurement of DE. Okay, let's see what we can do here. But we know that DEF is 150, and we know something about it being bisected, so it's a division of 2. So divide 150 by 2, and you get 75. So DE must be 75. All right, check your progress. We know measurement of WUX is 160, and we're going to find the measurement of UX. Good, if you said 80, you are correct. We can only do that because we know that the chord is perpendicular to a radius or diameter. Okay, here's a real-world example, okay, using diameter perpendicular to a chord. So, ceramic tile and the ceramic stepping stone below, diameter AB is 18 inches long, and the chord EF is 8 inches long, and we're trying to find CD. Okay, so we know AB is, the diameter is 18, so we could, from here, right, I got blue pen, so from here to here, it says it is 8 inches long, and chord EF, so this chord from here to here, is 8 inches long, but we know by the 90 degree angle that's bisecting, so we know that this has to be bisected, right, to be a 4 because of the being perpendicular. And we want to find CD. Okay? We should be able to do this because probably can draw a corner here, right? And it looks like CD would be part of a right triangle. And this would be a radius of 9 because the diameter is 18. So it looks like we might be able to use the Pythagorean theorem to find the length CD. I'm going to draw it over here. So there's my CE, right? CE, and that's 9 because that's my radius. CD, though, is not a radius. That's the side we're going to look for. But we do know that ED has to be half the length of EF, which is 4. Right, so we can probably use Pythagorean theorem. So 9 squared minus 4 squared, and then take a square root. So there's our drawing. So diameter AB is perpendicular. There. So DE is half of 8 or 4, like we said. Then use Pythagorean theorem. So CD ends up being approximately equal to 8.06, approximately. All right. Here's a real-world example for you to try. Go ahead and pause your video. Trying to find VU. So it's pretty much the same type problem. Okay. You said 4.9. You are correct. So I'm going to draw this in here. We're going to have our VR being a radius. And since my QS is 14, this has to be 7. And since this chord is perpendicular to a diameter, we know RT has to be bisected, so this would be a 5. So we need to take 7 squared minus 5 squared. So we get 49 minus 25, which that would be 24, and then the square root of 24. And the square root of 24 is approximately 4.899, so they rounded up. So 4.898. So that's how you get an answer of C. Okay, one more theorem here. It says the following. In the same circle or congruent circles, two chords are congruent if and only if they are equidistant from the center. So, if Lx, the length of Lx, equidistant, so that means perpendicular distance, so this right here, that distance is equal to this distance, then we know that the two chords are congruent. Here's an example for us to try. Okay, we see that GH equals 24, okay, and we're trying to find PQ. Now, we're going to be, since chords EF and GH are congruent, they are equidistant from P. So PQ equals PR. Okay? So it tells us that EF equals GH. So that tells me, since those are congruent, they must be equidistant. So it's the fact that they told us up here that and that's what the if and only if statement. So if we go back to the theorem, okay, since this is an if and only if, it means it could be actually said the other way. So if these two are congruent, okay, if these are congruent, then we can say that these are equal. And that's how we're doing that. That's how an if and only if statement works. So we can, since we know that EF and GH are congruent because they have the same measure, then we know then they're equidistant. Therefore, we can set 4x minus 3 equal to 2x plus 3. So we get 2x equals 6, or x equals 3. And then we solve for PQ by substituting 3 back in, and we get a value of 9. Okay, check your progress. We're going to try to find RS. Good, if you said 15, you are correct.